Okay, so we saw very briefly on Wednesday what a sine and cosine curve kind of looked like. We talked about the midline and the amplitude and the frequency, which we'll talk about again. And they were of this nature, but there's a very specific look of a sine graph. I'll tell you, it looks more like this is the cycle that you use. And a cosine graph, as we'll see, looks like that. That's the cycle that you use. Truly, you could always shift one onto the other because this kind of continues forever. Same here. So you could always shift one onto the other. But if you think of something as a sine graph, the cycle that you would pick out looks like this, where it starts on the midline, goes above, and then comes back down, crosses the midline in the middle, and goes back down and back to the midline. So it starts and ends on the midline. A cosine curve doesn't. It starts at either a max or a min. The one I have drawn starts at a maximum. So the midline kind of goes through there. Starts at a max, heads down to the minimum, crosses the midline halfway in between, and then goes from the minimum back to the maximum and crosses the midline halfway in between. We're going to take a closer look at that by starting with a table of values. So I start with a sine table of values, and I have a unit circle here too because you kind of already know a lot of these. Like the sine of 0, if x is 0, the sine of 0 you should know is 0. And then the next number on my table of values is pi over 2, so that's right here. And that's like a 90-degree angle. So the sine of pi over 2 you should know is 1. And so we're here. And then the next angle I address is pi, and the sine of pi, if this was 0, then that's also 0. And the sine of 3 pi over 2, which is here, if that was 1, this is negative 1. So the sine of 3 pi over 2 is negative 1. And then we get back to the beginning again, so 2 pi is the same as whatever 0 was, so that's 0. So 5 pi over 2, right, this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is going to be the same as whatever pi over 2 is. And you see that this cycle is going to continue. 3 pi will be here, which is the same as pi. 7 pi over 2 is here, which will be the same as this. And the cycle will just continue. That's why these are cyclical and called periodic functions. So let's jump down to the graph, because one cycle is one full trip around the unit circle. So we have 0, 0, pi over 2, 1. I'm going to scale this just to spread it out. That'll be a half, so this I'm going to call 1. So pi over 2, 1 is this point. Pi 0 is that point. 3 pi over 2, negative 1 is here. And then back to 2 pi 0. So every curve, every kind of the one sine-like pattern, which you can see now right here, has 5 critical points, okay? In this particular case, you've got your starting point and your ending point, and then they're both on the midline, so you have a halfway point that's also on the midline, and then halfway between these two, you have your maximum, and halfway between these two midline values, you have your minimum. And what it does is it essentially splits those 5 critical points, split your graph up into 4 critical sections. You've got the section from 0 to pi over 2, where we're increasing, okay? That's because as you go around your unit circle, your values increase. 0, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. For sine, they increase. And they're positive. See how this is above the x-axis. And then as you go around here, you're decreasing back to 0, and that's the decrease you see in the second quadrant. So this is quadrant 1, and this is quadrant 2. Once you reach quadrant 3, we're still decreasing, but notice we jumped into the negative. Shouldn't that make sense? All students take calculus. Sine was positive here, sine was also positive here, but now it's negative. And it's increasingly negative towards negative 1. So this is Q3 till we get to negative 1. And then Q4, sine is also negative, but it's at least increasing back towards 0, and that's the piece you have here. What I will also mention and remind you of is the fact that the sine of any angle always stays between -1 and 1. Notice none of these numbers exceed 1 or go further down from -1 because you're taking the sine of something. Now that can all change if we use like 5 times the sine of x. Now that would put a multiplier of 5 out in front, that would stretch it. So that would change, but at least if you're just taking the sine of something, that part always has to be between -1 and 1. So key features that and by the way, this continues forever. Obviously we run out of space, but those points would go back to 1, back to 0, back to -1, and it also kind of continues off in this direction forever, which we may get to in a minute, and kind of you see that wave pattern going back towards -infinity. Our features are this. The domain is completely unrestricted, so it's all real numbers. -infinity to infinity. You could write it in interval notation as well. All real numbers can also be x as any element of the real number system. The range, however, is limited. It's from -1 to 1. So in interval notation, -1 to 1 with brackets, because we actually reach -1 and 1. It's positive, and we'll just talk about the first cycle of it. It's positive from 0 to pi, which is quadrants 1 and 2, as we know from all students take calculus, and it's negative from pi to 2 pi. And I'm using parentheses here because it's not actually negative at pi, it's 0. It's not actually negative at 2 pi, it's 0 there, but everywhere in between. And again, that's quadrants 3 and 4, which these two jive with the all students take calculus test. The period, how long is this cycle? And this is hugely important. The period, the cycle starts at 0 and ends at 2 pi. So the period is 2 pi. The midline, halfway between the max at 1 and the minimum at -1, the midline is right at 0. So that's y equals 0, horizontal line. The amplitude, how far above the midline does this go? 1 unit. How far below the midline should be the same, 1 unit. So the amplitude is 1. Okay? Even, odd, or neither. So we haven't talked about this in a long time. An even function is symmetrical to the y-axis. An odd function is symmetrical to the origin, and a neither function is neither of those. So I think it's a good time now to kind of think about the way periodic functions work, and if this has a period of 2 pi, then we could slide this whole cycle 2 pi units over. So every one of these points, if you kind of transition this over, it will give you the continuation. So it's 2 pi units over would be here for the starting point, and 2 pi units over would be here for the ending point. Now, there's a middle point, which would be here, and there's the middle between these, which is at -3 pi over 2, would be a maximum, and the middle between these would be a minimum. So if we sort of continue this, and then think about symmetry. Is this symmetrical to the y-axis? Like if I fold this over, is it going to land on top of itself? And that answer is no. Odd symmetry being symmetrical to the origin, does it look the same right side up as it does upside down? So I'm going to flip my paper upside down, and does that look the same as the original? And the answer is yes. Here's that sine original curve. So the answer is yes, it does look the same right side up as it does upside down. So a sine function, we're going to find out, is odd. Okay? Most of your homework is going to be just describing transformations. This is all great stuff. We're going to use it a ton, but it's just an introduction to the parent graph and all of its features. And we're going to look at the transformation. So we got to think back. Transformations, it's been a while. Regarding what sorts of things happen with all these. Now, I've inserted every transformation under the sun here. We have here's within the function. So this stuff is horizontal. So this is a horizontal compression by a half, because all things are backwards when they're horizontal. And this one is a horizontal shift right by pi over 2 units, which we'll do a lot more with, but for now it's just right pi over 2 units. This stuff that's happening outside the sine of x is vertical. So that is a vertical stretch by 2. And the plus 1 is a vertical shift up 1. And so this is kind of what a lot of your homework is going to be. I'll show you quickly. It asks you to graph the functions on your calculator, so you'll just type that into your calculator, always making sure you're in radians, and then sort of compare it with the parent graph. So I'll even show you this one, and you can just remember for when you do get your homework. This is the sine parent graph with a plus 3 means it's been shifted up 3. So if on my calculator I graph the sine of x as my parent function, and then I graph the sine of x and then add 3 afterwards, make your window from negative 2 pi to 2 pi. So that's going to kind of be the traditional window we want to look at. And your min and max, because I shifted up 3, I'm going to go from negative 5 to 5 just to show you what's going to happen here. So here's my sine parent graph, and here's it shifted up 3. So what shifted up with it was the midline. The midline shifted up with it. Other than that, the periods remained the same, right? It's still taking 2 pi to get 1 full cycle in, and the max and the min obviously changed. They used to be 1, they got shifted up 3, so now it's at 4. The minimum was at negative 1, that got shifted up 3, so that's now at 2. But again, 2 being the minimum, 4 being the maximum, the midline is now at 3, halfway between 2 and 4. So the midline that used to be at 0 got shifted up 3 and is at 3. So that's sort of what your homework is going to be like. I said the window from 0 to 2 pi. You can do negative 2 pi to 2 pi if you want. Obviously, you just see an extra rotation or an extra cycle in there. So on the back, we're going to do a very similar thing. We're just going to go through our cosines. Now, if you think about our unit circle values, the cosine of 0 is 1, and then it decreases to 0. The cosine of 90 is always 0. And then this is negative 1. The cosine of 180 is negative 1, and the cosine of 270 was also 0. So if we just fill in our table, we have cosine of 0 is 1, cosine of pi over 2 is 0, the cosine of pi is negative 1, 3 pi over 2 is 0, and then we're back to the beginning 1, and this cycle just repeats. 0, negative 1, 0. So our first cycle is going to be those 5 critical points. So again, I'm going to scale this graph. That's going to be my 1. And I'm starting at 0, 1. And I'm ending at 2 pi with a 1. Those are my 2 maximums. My minimum happens halfway in between there. So at pi negative 1, I have a minimum. So that's that point. I've got my starting point of my cycle and my ending point of my full first cycle revolution. My middle of that first cycle, which is a minimum. And then kind of halfway between a max and a min, we'll have a midline hit. And then halfway between the min and the max here, we'll have a midline hit. So that's pi over 2, 0, and 3 pi over 2, 0. And you see then the cosine parent graph, okay, which will repeat infinitely. So that will be a max, and it's going to turn around. And same thing here. Like we said before, this period is the same as the sine period. It starts at 0, and the cycle ends at 2 pi. So that's a length of 2 pi. So we can now shift this over 2 pi units and get kind of another cycle. So this point gets shifted 2 pi over. The end point gets shifted 2 pi over. So we've got the start and the end. This gets shifted 1 pi over and then 2 pi over, puts us at our minimum, and then we have zeros here and here as well. So we just see another cycle of it. Okay? Our domain here is the same. X can be any real number, or we could go negative infinity to infinity if we want interval notation. Our range is also the same. The cosine of anything has to be between -1 and 1. And we'll just focus on our first cycle for this next part. This is positive from 0 to pi over 2, including at 0, but not including at pi over 2. And then it's negative for a while, and then it's positive again over here from 3 pi over 2 to 2 pi. So on both of those occasions. Now, the reason for that, all students take calculus. You're positive, definitely in the first quadrant, always, and this is cosine. So we're positive again from 3 pi over 2 to 2 pi. So it's positive in quadrants 1 and 4. If you look at your graph, here from 0 to pi over 2, that's Q1. From pi over 2 to pi, that's Q2, and it's negative there. From pi to 3 pi over 2, that's Q3. Cosine is also negative there. And then we're back into our fourth quadrant, and we're positive again. So this ties in very closely with the unit circle, and all students take calculus stuff that we've been doing. The negative quadrants are the second and third quadrant. Well, no coincidence, that's from pi over 2 to 3 pi over 2, and if you look at your graph, that's what's happening there as well. Now the period we already talked about from 0 to 2 pi is, starts at 0, the cycle ends at 2 pi, so the period is also 2 pi. The midline is also right down the middle. Okay, we have a maximum at 1 and a minimum at -1, so halfway between those is your midline, right at y equals 0. Your amplitude, at least for the parent graph, is just 1. And even, odd, or neither. Is this symmetrical to the y-axis? If I flip this over the y-axis, aka my yellow pencil, is it going to land on itself? Yes, it is. So this is an even function. And then down below I have another describe the transformation. So again, I have every transformation pretty much under the sun here. I'm going to start on the inside of the cosine because all of this stuff is horizontal. That's a horizontal stretch by 2. This is a horizontal shift left 3. When you go to the outside, negating. Outside is vertical. Negating means reflection. So it's a vertical reflection over the x-axis. And this is a vertical shift down 2. So as far as describing, you might have that many in one problem. But when we get to graphing by hand, you're not going to have more than, definitely not more than 3. But usually you're only going to have 1 or 2, maybe 2 transformations per problem when you're going to be sketching these by hand. So that's all there. I'm just quickly looking if there's anything else I want to talk about, even on your homework. All of these first examples only have one transformation. Horizontal shift, vertical stretch, horizontal compression, vertical flip, horizontal flip. That should probably be in parentheses. It's only down here where I start giving you, there's multiple transformations that you have to worry about describing. But again, I want you to use your calculator to graph the sine parent graph all on this front side, and then alongside, so you have 2 graphs on one, there's your parent graph and then that one. So that when you're looking at it, you can really see the transformation from your original to the new, and you can confirm what you thought your description was. And then the back side is all cosine. So you start with your cosine parent graph and then graph this one next to it. Make sure your calculator is going to open parentheses. Make sure you close the parentheses right after whatever you're taking the cosine of, because this -2 is meant to happen after the fact, whereas this -2 you're trying to take the cosine of the entire thing. So you would keep the entire x minus 2 in parentheses. So your homework is just this worksheet. You can get started on it with whatever time you have left. And then this homework after break, and also the intro to periodic functions from Wednesday, we'll look at this all after break.